LIGO's ChromaTOF Sync is an advanced peak finding tool for processing sets of Pegasus BT data. With full peak finding and deconvolution, the software generates a combined peak table for multiple samples, simplifying non-targeted characterization workflows. Here we are highlighting an application project that used ChromaTOF Sync to explore the chemical profile of a beer and how it changed over time. We had a fresh sample and samples that had been aged at room temperature for 1, 2, 4, and 10 weeks. For these samples, we also had associated sensory data. Each beer was scored from 0 to 8 by a trained panel. A higher score indicated that the beer had more of the expected flavor profile and no signs of aging, and a lower score indicated a loss of the flavor profile with increased signs of aging. We can see that the sensory score decreased pretty dramatically over the 10-week period, from above 7 to under 3. We analyzed these samples in triplicate with the Pegasus BT. Our primary goal was to characterize the aroma profiles so that we could see how the chemical information may relate to these sensory changes. ChromaTOF Sync facilitates this task by processing all of the data together and compiling analyte information into a single combined peak table. Here we can see the processing results and the options for reviewing the data for our set of samples. The table across the bottom has the peak find results and information about the analytes, including name, similarity score, retention index, and other identification metrics. In the top corner, we have the deconvoluted spectral information and the library match. We can see the chromatographic peaks for each sample, either overlaid or side by side in the tab at the top. We can also view the relative trends across the sample set with the area lines or area bars. The peak area information for all 15 samples is also tabulated in these columns at the back of the table. These can be displayed with the values or as a heat map, which is another nice way to visualize the trends. This analyte is one that increased over the time course. We can see other trends as well. Some remained fairly consistent and others decreased. Some of these analytes are obscured by coelutions, but deconvolution helps uncover these so we can see more analytes and their trends. We can continue to look at individual analytes, and we can also perform additional comparisons with our compiled data like principal component analysis. Here in the scores plot, we see that the samples group by their age and generally follow a trend similar to the sensory score. Overall, we see a nice connection between the chemical information and the sensory trends. We can explore the analytes that increase to understand the signs of aging, and we can explore the analytes that decrease to get a sense of the flavor profile that is diminishing. ChromaTOF Sync compiles information about the entire sample set so that we can perform this type of non-targeted data review to better understand our samples. Getting to this combined feature table is straightforward with a familiar data processing method. We start by creating a new alignment method in the ChromaTOF Sync software. We select the samples to process from our ChromaTOF database. Then we specify data processing parameters like signal to noise, peak width, and expected retention shift. The library search parameters and retention index landmarks can also be entered before clicking Begin to start the data processing. After processing, the software takes us directly to the results where we can review individual analytes, perform additional analyses like PCA, and start to understand the similarities, differences, and trends in our data set. In this example, we explored the chemical changes related to the aging of a beer sample, but this tool can help with non-targeted characterizations of many types of samples and applications.